I welcome you all for the next session, which is on derivation of differential equation. Here in this concept we are going to find out the natural frequency of a spring mass system by different methods. The equation of motion for a single degree of freedom system can be found by employing many methods. The methods may be either first one is a Newton method, second one is a energy method, and third one is a Rayleigh's method. So let us discuss the methods one by one. So let us start with the first method, that is nothing but it is a Newton's method. Consider a spring which is free at one end and fixed at other end as shown in the figure. Let the stiffness of the spring is K. If I attach a mass at the free end of a spring, then the length of the spring is increased, or we can say that the spring is stretched with an amount, say delta, as shown in the below figure. So here we have two figures. One is the initial spring with a stiffness K, and another one beside the initial spring there is another spring, the same spring, to which I have attached the mass. So when I have attached the mass at the free end, so the spring is going to be stretched. Now the weight of the mass is given by W is equal to m into g, where m is the mass and g is the acceleration due to gravity, and this weight will be acting in the downwards direction. For this downward action of the mass, there will be an equal and opposite reaction in the upward direction. Hence, the resistance force which is acting in the upward direction is K into delta, where K is the stiffness of the spring and delta is the expansion taken place after attaching the mass at the free end. And it is shown in the figure here. The figure shows, or the free body diagram shows, when I apply the mass to the spring, the weight will be acting in the downward direction, and which is nothing but m into g. For that downward action of the mass, there will be an equal and opposite reaction in the opposite direction. So therefore, if we consider the equilibrium of the system, then for the equilibrium of the system, the downward force should be equal to the upward force, and the downward force is given as m into g and the upward force is given as k into delta. Now let us consider the same spring. If I apply the downward force on the mass which is already attached on the spring at the free end, then the downward force is given by m into x double dot. When you apply a force on the mass, then it will result into an accelerating force with a magnitude of mx double dot in the downward direction. So now therefore the restoring force will be same in the magnitude but opposite in direction. That restoring force for the applied force is same as mx double dot, but the direction will be opposite to the applied force. Now if I consider the equilibrium of the spring mass system, then the downward force should be equal to the upward force. The downward force is given by m into g, which we have seen in the equation number 1, and the upward force for the spring mass system after the application of the external force is given by mx double dot plus k into delta plus x, where delta is the initial displacement taken place after attaching the mass and x is the additional displacement taken place after I apply the downward force on the mass. So therefore the total upward force or the total restoring force which is acting in the upward direction is, one is because of the external force which we have applied, that is mx double dot, plus k into delta plus x, which is the expansion of the spring taken place after application of the force. So therefore mx double dot plus k into delta plus x, I am going to take mg from left hand side to this side, so it becomes minus mg, which is equal to 0. Now expanding the bracket, mx double dot plus k into delta plus kx minus mg is equal to 0. From equation 1 we know, if I consider the equation number once again, the downward force is equal to upward force, and that is nothing but mg is equal to k delta. Now using the same equation here, we have the equation mx double dot plus k delta plus kx minus mg is equal to 0. From equation 1 we know that m into g is equal to k into delta. So wherever mg is there, if you substitute k delta, then it becomes mx double dot plus k delta plus kx minus k delta. So therefore k delta and mg gets cancels. So the remaining term will be mx double dot plus kx is equal to 0, which is nothing but equation number 2. Comparing the above equation with the standard equation, that is x double dot plus omega n square into x is equal to 0. Therefore dividing the equation number 2 by m, the remaining term will be x double dot plus k by m into x is equal to 0. Now compare the equation number 3 and equation number 4. We can find out the value for omega n. By comparing the equations 3 and 4, we can write omega n square is equal to k by m. Therefore omega is equal to under root of k by m, where omega n is the natural frequency of the system. The same natural frequency can also be found out by different methods. So we have discussed now the Newton's method. So let us find out the natural frequency of a spring mass system with the help of energy method. In a conservative system, the total sum of the energy is always constant. But in a vibratory system, the energy is partly potential and it is partly kinetic. The kinetic energy is denoted by T, and it is because of velocity of the mass, and potential energy is denoted by V, and it is stored in the spring because of its elastic deformation. According to the conservation law of energy, the kinetic energy plus potential energy will be always equal to constant. Differentiating the above equation with respect to time is 0, hence d by dt of t plus v is equal to 0. The kinetic energy and potential energy for the system, which is shown beside here, that is nothing but a spring mass system, is given by the kinetic energy is given by T is equal to half into m into v square, where m is the mass and v is the velocity. We already learnt that the displacement is given by x, velocity is given as x dot, and acceleration is denoted as x double dot. Hence the above equation can be replaced as half into m into x dot square, and potential energy is given by half into k into x square. Now substituting the values of t and v into the above equation, then it becomes d by dt of half into m into x dot square plus half into k into x square is equal to 0. Now differentiating the above equation, we are remaining with m into x double dot into x dot plus k into x dot is equal to 0. If I take the x dot outside, then the remaining term will be mx double dot plus kx is equal to 0. Comparing the above equation with the standard equation, that is x double dot plus omega n square into x is equal to 0, and dividing the equation 1 by m, so we are arriving at x double dot plus k by m into x is equal to 0. Now comparing the equations 2 and 3, we can find out omega n square is equal to k by n, and omega n is equal to under root k by m, where omega n is the natural frequency of the system, and the frequency of vibration is given by fn is equal to omega n by 2 pi, or fn is equal to 1 by 2 pi into under root k by m. So now let us find out the same natural frequency with the third method, that is nothing but Rayleigh's method. In deriving the expression for the motion, it is assumed that the maximum kinetic energy at the mean position is equal to the maximum potential energy at the extreme position. The motion is assumed to be simple harmonic. Then the equation is given by x is equal to a into sine omega n into t, where x is equal to displacement of body from the mean position after time interval of t, and A is equal to the maximum displacement from mean position to the extreme position. Now differentiating the equation 1, we get x dot is equal to A into cos omega n into t into omega n. The maximum velocity at mean position is x dot is equal to A into omega n because for maximum value of cos it will be 1. So maximum kinetic energy at mean position is given by half into m into x dot square. So if I substitute the value of x dot as A into omega n, which we have got after differentiating or after getting the maximum velocity, so half into m into a square into omega n square. The maximum potential energy at the extreme position is given by half into k into a square, which is given as equation number 3. Now equating the equations 2 and 3, we get half into m into a square into omega n square is equal to half into k into a square. Half from both the sides gets cancels, a square from both the sides gets cancels, so remaining term will be omega n square is equal to k by m. Therefore omega is equal to under root k by n, and frequency is given by 1 by 2 pi into under root k by m. So these are the three different methods to find out the natural frequency of a system. So all these three methods are very important, which have been asked many of the times in the SW examination. If you have any doubt, please clarify and contact to my personal WhatsApp number. Thank you.